Hello students, welcome to classroom. I hope you're all doing well. In today's class, together we will be learning about image formation cases for convex lenses. Now, in order to easily understand this, you need to be thorough with the rules for drawing ray diagram for lenses. Okay, so in the previous video, I have discussed about it, so I will request you to have a look at that first. Okay, and if you have already seen that and if you are thorough with the rules, then this is going to be an easy task for you. So let us start with the class now. So image formation cases for convex lens, there are 6 cases. We will discuss them each one by one. Let us start with case 1. So let us have a look at case 1. Now, oh, that's a loud thunder. Okay, so what we write is, we write the object position. So object position, let me just use small letter here, object position. Okay, it's similar to mirrors only, object position, then image position. These things we have already written in mirror. We will be repeating the same thing again. So image position, where the image will be formed, then the size, and finally the nature. Okay, so these 4 points are very important to whenever we study the image formation cases, either for lenses or mirror. So now what we have to do is we have to draw the ray diagram for case 1. So for case 1, the ray diagram will look like this. So we draw the convex lens, and we do not forget to mark the aperture. This is the aperture. It is very important. Okay, in exam, do not forget to label the aperture. Okay, then this is the principal axis which passes through the center of the lens, and it also passes through the center of the aperture. The center of the aperture will be marked as O for optical center. Okay, in lens, in mirror, this is P, principal axis. Okay, but for lenses, it is optical center now, O. Now, you know how it goes. Okay, in case 1, the object is kept at infinity. Then in case 2, the object will be visible. In case 3, the object will be more closer to the lens. In case 4, again more closer. Okay, likewise, the object moves closer and closer to the lens. Okay, remember that. So in case 1, since this is case 1, object is, we cannot show the object is not drawn in front of the lens, but we will consider 2 rays coming from the object. So the object is kept at infinity. So object position in case 1 is at infinity. All right, at infinity, object is at infinity, and we will be considering two light rays traveling parallel to the principal axis. So let us draw that. So let this be ray number 1 and let this be ray number 2. So both the rays are traveling parallel to the principal axis. They should be parallel. Okay, now which rule do we follow? There are only 3 rules. Okay, rule 1, when the incident ray travels parallel to the principal axis. Rule 2, when the incident ray enters through focus. And rule 3, when the incident ray enters through optical center. Okay, these are the 3 rules. When the incident ray enters through optical center, there is no deviation. Okay, so which rules will I follow? Since the incident ray is traveling parallel to the principal axis, I should be following rule 1. So let me show you the F1 here. Let this be F2. Okay, cannot be F1 here. F1 is on this side. Okay, remember in lenses we have 2 focuses. We have one focus on the left side, the other on the right side. The one on the left one is considered F1. Okay, then we have our 2F1, then this is F2. Okay, and exactly the same distance, if you go ahead, you have to mark here, which will be your 2F2. Okay, it goes on like that, F2 to F2. Okay, and the refracted rays will be that F2. So we have to draw like this and like this. Okay, so these are the refracted rays. Okay, undergoing refraction from the convex lens. So image position, we have to write the image position. Where is the image form? Image is formed at F2. So you'll have to write here at F2. Okay, size. What is the size of the image? The size of the image, it's point size only. Okay, highly diminished or point size. According to your textbook, okay, both are written highly diminished, point size. We can write point size because that's how it's visible to us. So point size. let it be size, point size. Okay, nature, real and inverted. Remember that if it is real, then it will be inverted for lenses. Okay, so real and inverted. So this completes our case 1. Okay, now we could proceed to the case 2. Case 2. I want all of you to grab a book, a pen or a pencil, and then copy down the notes. Okay, you learn better if you follow and if you participate. Okay, so we learn better when we participate, or else though if you just listen and listen, we will understand at that moment, but again we forget. So memory retention is better if we use our hand and if we practice along with. Okay, so that's how we should learn. So case 2 now. In case 2, again the same thing continues. Object position, we have to write it. Then image position, then we have to write the size also, where what will be the size, and then the nature. Okay, so now time to draw the ray diagram for case 2. In case 2, first of all we'll draw the convex lens. So this is the convex lens. Okay, then the principal axis which passes through the optical center. Then now let's mark our f1 and f2, similarly 2f2 and 2f1 also. So for that, let's say this much is my focus, so I'm going to use this as my f1. So I'll measure the same distance and go back again and then mark my mark here. So this will be my 2f1. Remember, okay, f1, this side, the left side is for f1. Okay, so you have your f1, then you have your 2f1, and the right side belongs to f2. You'll have your f2 and your 2f2. Okay, so same distance, take it and go this side. So basically one time here and another one here. So you have your f2 and you'll have your 2f2. Okay, it is very important to mark these points on the principal axis. Now this is case 2. The object will be visible. So where will the object be? The object will be behind 2f1. Previously it was not visible. Okay, it was not visible, it was at infinity. Now the object will be visible, but it will be behind 2f1. So the object is behind 2f1. So let us draw the object. Let us use this as our object. Okay, so we'll consider 2 light rays from the tip of the object, which is this. So ray number 1 will follow which rule? We are following rule 1. Okay, the incident ray, this ray traveling parallel to principal axis, this is following rule 1. So we know if the ray is traveling parallel to principal axis, after refraction it will pass through f2. Yes, so it will pass through f2. So let it pass through f2. Okay, now the second one, what will happen? The second one will enter through optical center. So the second one will aim the optical center, and we know that any ray which enters the optical center, it passes through without undergoing any refraction. There is no deviation. That means without any refraction it will pass through. So that is rule 3. We are following rule 3 here. So we are following rule 1 and rule 3. So let's do that. So this practice. Okay, I'm used to paper and I'm used to doing in books, but in whiteboard even I'm not very confident. So let's see. I hope I got it. I hope I get it. I hope it's straight enough. Okay, well, the image is supposed to form it between f2 and 2f2. So the image is from here. Okay, so this is the image. Okay, the image is from here. Okay, it should be straight, so you can use a scale. Okay, and remember the image is supposed to be formed between f2 and 2f2. Okay, for case 2, the image is supposed to be formed between f2 and 2f2. So where is the object position? Let's write it now. The object is behind, okay, behind 2f1. Okay, this is behind 2f1. Sometimes I think in the textbook it's written beyond 2f1, so we can write beyond. Okay, beyond 2f1 means the object is kept beyond. Remember, we start our measurement from here. Okay, so from here the word beyond is correct. Okay, because to reach to this point, you have to go beyond 2f1, isn't it? After going beyond 2f1 only, you will meet the object. So beyond is the right word, okay? Behind also is correct, beyond also is also correct. Image position, where's the image? It's between f2 and 2f2. So you will write between f2 and 2f2. Size, well, size, the object is bigger, the image is smaller. So here we'll use the word diminished. So you will be writing diminished. And nature will be real and inverted. Real and inverted. So this ends the case 2. Now we have case 3 and case 4. So let us write those two cases here, case 3 and case 4. So now we'll go to case 3 and then we'll be writing the same thing. So let me just erase this because these things will change but the headings will not change. So, and even the ray diagram will change. So let me erase these things. Now we are going to case 3. So time to do the ray diagram. So let us do the ray diagram. Mark the aperture, draw the principal axis, and then mark the optical center, get your focuses. So let this be f1, then same distance, then I go on the right side also, okay? So this is my f2 and this is 2f2 and this becomes 2f1, okay? Now in case 3, the object will be at 2f1, so the object will stand at 2f1, okay? Then let us draw the ray diagram. So object position at 2f1, okay? So first one, rule 1, we'll follow rule 1, okay? So I'll follow rule 1. So in rule 1, the incident ray travels parallel to the principal axis, which after refraction will pass through f2. So it goes like this. And the second one will follow, I will take rule 3 again, okay? In case 2 also I have used rule 3. Even here again I will use rule 3. In rule 3, the incident ray enters through optical center, okay? And then the ray passes straight without any deviation. So rule 3. Yes. So the image is from here, okay? Below, okay? The image is from exactly at 2f2, okay? This may need a little bit of practice. So maybe at one go you may not get it, okay? So this needs this is the case which needs a lot of practice. So make sure that you get it exactly below, exactly at 2f2, okay? The image is supposed to be formed at 2f2, so the image should be at 2f2, okay? Not beyond or not in front, okay? It should be exactly at 2f2, okay? So these are the two refracted rays and then they meet here, okay, which is at 2f2. So object position at 2f1, image position at 2f2, at 2f2. Now it is in this case that the image height is equal to the height of the object, okay? So size is same as object, okay? So the image height is same as object, okay? Remember this. Here in case 2 it was smaller, okay, but here same as object. So the image height is same as object and nature is still real and inverted. All right, now we go to case 4. So we go to case 4 now, case 4, and the headings will still remain. So I will not erase the headings. The ray diagram will change. So now we are at case 4. So let's draw the convex lens, mark the aperture, draw the principal axis, and then mark the optical center. Then take your focus, so let this be my f1. So taking the same measurement, I go to get my 2f1. Using the same measurement, I go forward on the right side to get my f2 and 2f2. So this becomes my f2 and this becomes my 2f2. Now, where will the object be? The object has already stood at 2f1 in case 3. Now the object will stand between 2f1 and f1. So the object will stand here. Okay, the object will stand here between 2f1 and f1. So the object stands here between 2f1 and f1. So object position should be written between 2f1 and f1. Okay, between 2f1 and f1. Then time to do the rays. So first ray, rule 1. Second ray, rule 3. So rule 1, incident ray traveling parallel to principal axis. After refraction, it passes through f2. Yes, correct. It passes through f2. Then ray 2, case 3. It will enter through optical center and it will go, okay, without any deviation. So let it enter through this, and then where do they meet? They meet at this point. So it is here. Okay, it's beyond 2f2. Okay, the image is from beyond 2f2. So image position beyond 2f2. The image is formed here at this point, which is beyond 2f2, because measurement starts from here. So in order to reach to this point, you have to go beyond 2f2. That's why the image is formed beyond 2f2. Okay, size. Look at the size. The object is this much. The image is a little bigger. So here, this is enlarged. Okay, size is enlarged. Okay, and nature will still be real and inverted. All right, now we go to fifth case. The fifth case, these arrows are very important, class. If you do not write the arrows, you'll lose marks, so make sure that you write the arrows. Okay, then we have the fifth case now. So let us have a look at the fifth case. Let me erase these things, and then even the ray diagram. Now fifth case, let us draw the ray diagram for the fifth case. This is the convex lens. Then the principal axis is here. Then this is the optical center. Then let's mark our focuses. F1, let us start with F1. So let me say this much is F1. Then I go back again to get my 2F2. So this is F1 and this is my 2F1. Sorry, I said 2F2. Then to get my F2 and 2F2, I go towards my right side, get me my F2 and 2F2. So this is F2 and 2F2. Now this is case 5. Where will the object be? The object has already stood between 2F1 and F1. So now the object will stand at F1. So the object will stand at F1. So let us draw the object here. The object is at F1. Okay, time to draw the rays. So let's draw two rays. As usual, we will follow rule 1 and rule 3. So rule 1 should be parallel. Okay, should be parallel. Make sure that it is parallel. So let's make it parallel. Okay, incident ray traveling parallel to principal axis. After refraction, it passes through F2. Okay, it passes through, focus only. The second ray, I'll use rule 3. It will enter through optical center. So it will go like this. Okay, so here the refracted rays, they travel like this. Okay, parallel. The refracted rays, they are traveling parallel to each other. So the image is formed at infinity. So the image will be formed at infinity. Okay, nobody knows where the parallel rays will meet. Maybe they meet at infinity. So let's just write infinity. Object position at F1. So at F1 and image position at infinity. At infinity. Okay, at infinity. Size highly enlarged. Okay, highly enlarged. Images which are formed at infinity are considered to be very big. So highly enlarged. Highly enlarged. And nature still real and inverted. In terms of lenses, all real images are inverted. Okay, then the last case 6. So now we have the last case 6. Let us erase these things because these things will change, and then we'll draw ourselves a new ray diagram again. So this is case 6, and again a very important case. So let's put star mark here. Okay, this is a very important case. So let us draw the lens now, convex lens. We have marked the we have marked the aperture. Time to do the principal axis. Time to mark the optical center. Optical center has been marked. Time to label the focus. So let's say this is my f1, then this becomes my my 2f1, then this is my f2 and my 2f2. So this is f1, this is 2f1, this is f2, this becomes 2f2. all right, now the object has already stood at f1. In case 5, the object has already stood at f1, so the object will move forward closer to the lens, closer to the optical center. So the object will now stand between O and f1. So the object will stand between O and f1. So let's say this is the object. Okay, again we'll be using our all-time favorite rule 1 and rule 3. Okay, rule 1 and rule 3. So rule 1, like this. Okay, incident ray traveling parallel to the principal axis, after refraction it will pass through focus. So it will pass through focus now. Then rule 3, the incident ray will enter through optical center. So the incident ray will enter through optical center. So it will go like this. Then no deviation. The ray which enters through optical center, it does not undergo any deviation. It goes like this. So now if you look at the refracted rays, okay, they are not going to meet at this point. Okay, they are not going to meet they are not going to meet, rather they are going further away from each other. So if you follow ray 1, it's going in this direction, and ray 2 is going in this direction. So the distance between them is ever increasing and ever increasing and ever increasing. Okay, they are not parallel. Okay, they are not parallel, unlike this where they are parallel. Here they are not parallel. So what we can do is, well, they are not going to meet in this scenario. Okay, if we trace this path, they're only going to get further away from each other. The distance between the two rays is only increasing and increasing and increasing with time. Okay, so what we do is we backtrace it. On backtracing it, okay, the two rays, they will appear to meet somewhere here on the same side as the object. That's what we are going to do. So what we do is we backtrace it. The backtracing will be done with dotted line. So with dotted line, you try to backtrace it. Remember, it should be with dotted line. And then on backtracing it, we find the image, the two reflected rays to meet somewhere here. They meet here. So this is where the image will be formed. Okay, on backtracing it, they meet here on the same side as the object. Okay, and this is where the image will be formed. It will be a virtual image. This is the only case in convex lens where we get a virtual image. That is why this is a very important case. Okay, so object position at f1, between f1 and optical center. Okay, then image position, well, you don't need to write any specific position for the image. Just you have to write on the same side as object. That will do. Okay, on the same side as object. Image position on the same side as object. Okay, you can just write same side as object also. You can just write same side as object. Same side as object. This will do. Same side as object. The image is formed on the same side as object. Okay, you don't need to know where it is. Okay, some of your figure the image may even be formed here, so no need to worry. Okay, they don't ask you exactly at what point, they just want to know, okay, on which side it is formed. So just say on the same side as object. Okay, size, this is enlarged. Okay, it's highly enlarged or enlarged, so we can write enlarged also. Okay, object is this much and image is this much, so we can write enlarged. We can also write highly enlarged also. Okay, highly enlarged, so we can write. Okay, then nature, well, this is for the first time a virtual image, and remember class, virtual images are always erect. So virtual and erect. Virtual because, you know why it's virtual? It's virtual because the two refracted rays, they do not actually meet. Okay, but okay, they appear to meet. On backtracing it, they appear to meet. Whenever images are formed by refracted rays which they appear by refracted rays which appear to meet, we get ourselves virtual images. Okay, so this is a virtual images. This is a virtual image because the two refracted rays, they actually do not meet, but then they appear to meet. That's why this is a virtual image. And then look at it, this is an erect image. Okay, virtual and erect. So virtual and erect. Virtual and erect. So this is the sixth case, and this was the last case. Okay, so for convex lenses we have 6 cases. We have discussed all the 6 cases. Now in the next video we'll discuss about for concave lens. There are only 2 cases for concave lens, and likewise we'll discuss about magnification and lens formula, okay, which will be in the next video. So stay tuned, and I'll see you again in the next video. Till then, God bless you all.